Okay, welcome to the next phase of this video, guys. And we completed with question number 3 in the last phase. Now we are coming to question number 4. Now the question number 4 says complete the truth table for the logic expression. So over here they are saying A and A, sorry, not A and B, that is XORing with not B and B nor C. So what you can do, you can say A and B is equivalent to P, and it's a bar over that. So you may say it's a P bar. Whereas it's going to XOR with not B, so you may say B bar to this part, ending with B nor C, so you can say it as the uh sorry, don't, you can't say that as B. Yeah, you can say that with B bar, and you can just say it as Q. And finally, the product of B bar dot Q could be equivalent to you may say R, and P bar is XORing with R, so you may say it will be equivalent to X. So we need to find out first of all P, then we need to find out P bar, then B bar, then Q, then R, and finally X. So A and B, what will be the answer for A and B? We can check it out. NAND means that output will be high, or you may say output will be low if all the inputs are high. So for 0 0 it will be a 1. Again for 0 0 it will be a 1, 0 0 0 1 it will be a 1, 0 1 it will be a 1, 1 0 1, 1 0 1, 1 1 it will be a 0, and 1 1 it will be a 0. P bar will be the opposite of this part. So we do have 6 zeros in continuous, and finally we do have 2 ones at the bottom. So we have done till here. Now we need to XOR it with the R. So finding out the R, so first of all B bar, so that will be a revert of B. So that will be 2 ones, 2 zeros, again 2 ones, and again 2 zeros. Now it's going to end with Q. So first of all, we need to find out the Q. Q is B nor C. B nor C. B nor C says that output will be low if any or all of the inputs are high. So that means only in the condition, if it's a 0 0, only in this condition it will be a 1, otherwise it will be a 0 because it's a NOR. So for 0 0 it will be a 1, 0 1 it will be a 0, 1 0 it will be a 0, 1 1 it will be a 0, 0 0 it will be a 1, 0 1 it will be a 0, 1 0 it will be a 0, and 1 1 it will be a 0. Now R is basically um, the AND gate between B bar and Q. B bar and Q AND gate. So 1 1 is 1, then 0, then 0, then 0, 1, 0, 0, 0. Now we need to find out X. So X is the XOR gate between P and R. So R and P. Sorry, R and P bar. Sorry, my bad. R and P bar. So it will be a 0 1 will be a 1 because dissimilar elements are 1. Then 0 0 it will be a 0. 0 0 0 0 0 it will be a 0. Then we do have 0 1 1. Then we do have 0 0 it will be a 0. Then we do have 1 0 it will be a 1, and 1 0 it will be a 1. So you will be awarded with 2 marks for this part. Okay. So how you awarded with 2 marks? First 4 till here 1 marks, and the remaining 4 will be of 1 mark. Okay, now we need to draw up the logic circuit. Now how are we going to draw up the logic circuit? We are saying A and not, not for what? B or C. So first of all, we need to find out B or C. So we will be taking out B. Or implementing a not over it, and it is going to end with A. Okay. Now it is ending with B nor C. So we can just have a connecting thing over here. B, that's a jump, and B nor C. and it will be a AND over here. You can take a bit different thing over here. Yeah, now much better. So that's how you need to do it. So 2 marks for this one as well. Okay, now they are saying question number 5. So for the question number 5, they are saying a central processing unit CPU of the basic von Neumann model for a computer system contains several purpose registers. The memory address register MDR, index register IX, and the accumulator ACC are examples of the special purpose registers. Define two other special purpose registers and state their role in the CPU. Okay. So in the von Neumann model, we are utilizing the MDR, we are utilizing the index register, we are utilizing the accumulator register. We do utilize the program counter, we do utilize the CIR, we do utilize the status registers, we do utilize the MAR. Okay, that's all you can find in your notes as well. Okay, now special purpose registers. So for the special purpose register, first of all, we can write with the program counter. So we can write it over here. Holds the address. It is holding the address of the very next instruction that needs to be fetched. Okay, now coming towards the special purpose register 2. Okay, now what is the special purpose register 2? As I told you that it could be the status register, it could be the CIR, or it could be the MAR. So MAR will be storing the address. So we can write down the CIR because it will be like somewhat similar to the program counter. So we can have a CIR. CIR means current instruction register. Okay, if I'm not left with the space for the CIR, that does not matter because I have written the complete name for it. Okay, now what does it hold? It holds the instruction currently being decoded. Do remember it is holding the instruction, holds the instruction currently being decoded or processed or executed. You can write, you cannot write executed because once it needs to be decoded, you can write in this manner decoded and then executed. You can write it in this manner, but directly cannot write executed part. Okay, now they are saying describe what is meant by the immediate access store in a computer system. Okay, now the students who are my students in the regular classes, so I just told them it's the second name for the general purpose registers as well. So what is the functionality of this thing? Okay, so it's for the 2 marks, so that means we do require the 2 points over there. Okay, now 2 point means we cannot write it in the point format, we need to do it in the paragraph format. So it's a volatile memory. Volatile memory space that have a faster access time, and it holds the data currently in use. Actually, I have written 3 points over here, so you may write 2 points. So the last point, holds data currently in use, is the important point. Apart from that, you can write like volatile memory space, or you can write with the faster access time of the data. Okay. Okay. Now coming towards the third part. Now third part is regarding the structure. Now what do they say in the third part? They are saying a computer has a single 2.1 gigahertz CPU. That means a microprocessor is there and a single microprocessor of 2.0 gigahertz. The frequency has been told to you. Describe how increasing the clock speed to 4 gigahertz can increase the performance of the computer. Okay, now obviously once you are going to increase the uh, processing speed, so what will be the uh, effect of that on the performance of the computer? Now obviously 2.1 and 4 approximately double, so it can process the thing approximately at double, or you may say in a half of the time. Okay, um, so this is the major thing, and because for 1 mark, so you can also write it will increase the processing speed, or you may write it will increase the processing speed up to double. You can write because they have given you up uh, the values over here. So will increase the processing speed to approximately to approx double. That will be fine. To approx of double of speed, regular speed. You can write it down in this manner. Okay, our second computer has a CPU with two 2.0 gigahertz cores. Okay, explain why the second computer does not always run twice as fast as the computer with one 2.1 gigahertz. Now they are saying it is having two cores that was having a one single processor. This one was having one single processor. Now it is having two processors, both of 2.1 gigahertz. Now they are saying it won't be executing at the same ratio as it was executing with once we have in once we have just increased the power of the processor in the previous part. So why is that so? So let's see how many marks. Okay, now that's for the 5 marks. That means you need to 5 marks. You need to place the 5 points over here. Now, what is the major issue with that thing? The major issue is that um, multiple cores. If there are multiple cores, that means there are two cores over here. So they are going to introduce the additional overheads. Now, what do you mean by the overheads over there? That means there are the things are divided into multiple other things. So obviously that will be reducing the speed. Apart from that, the software that you are working on may not be designed for the multiple cores. So it might be sending the data to only one of the core. It won't be sending to both of the cores at the same time. Similarly, you may say uh, process access may not like they might not be synchronized completely. Apart from that, you may say the two computers may have different than just the cores. That means one is having more RAM, the other one is having less RAM. One is having more IO, one is more IO bond, the other one is less IO bond. So these could be few of the factors over there. So let me just write it down for you guys. Memory access may not match with speed of cores, causing a delay. Apart from that, you may write also software may not be designed for multi-core purpose as multi-core may have additional overheads that requires all codes to be synchronized for execution of data. So these could be few of the factors that you can write over here. Now for the sixth question, they are saying a programmer uses both a compiler and an interpreter to translate a program written in a high-level language. Compiler means that is converting the entire program at once, whereas interpreter is converting the program instruction by instruction. Okay, written in a high-level language, that means a human understandable language. Now they are saying describe the advantage of using the interpreter compared to the compiler to translate the program. Now you do have 4 marks. So you do require the 4 advantages obviously over here. So the advantage of an interpreter. Number one, easier to debug as each statement is executed. No, you cannot write in that man. As as it executes, you can write in this manner. As it executes instruction by instruction or line by line, instruction by instruction. Do remember 4 points, okay? Halting the program as soon as it finds an error to correct that. Okay. The second thing you may see, you may write over here. Once program is corrected or error is corrected, it checks again from initial till further and repeats the process until end of program. Okay. Quite beneficial. You can also write it down. Quite beneficial. Quite beneficial while developing as software. So you can write it down in this particular manner. Now they're saying state one reason why some high level languages are partially compiled and partially interpreted. So now they are asking you one reason why few of the high level languages, that means the human understandable language, why they are partially compiled and partially interpreted. So that's for 1 mark. So you may write it down. Source code. Source code is any program written in the high level language. Source code do not require to recompile. So it's more efficient. as it does not require to recompile again and again, so it's quite more efficient. Then they are saying identify two features that support the visual presentation of the code in a typical IDE. Okay, so it could be pretty typing, it could be auto indentation, it could be auto documentation. So multiple of the things could be there. Auto correction could be there as well. But they are talking about the visual presentation. So mostly you may write pretty printing, pretty typing, auto indentation. These could be few other things majorly. Okay. So you may write pretty printing. And apart from the pretty printing, you may write auto indentation. Okay. I identified two features that support the debugging of the code in a typical ID. Okay, now debugging. Debugging means that you need to find out the errors. So what could be the things through which you could find out the errors? So report window is over there. Variable expressions is over there. Breakpoints are over there. Breakpoint means that as soon as there is an error, so it would be breaking up over there and will be telling you. Single stepping is over there. So there could be multiple things. So mostly we can write it down with breakpoints. Okay, just after the breakpoints, we can write variable expressions. So these could be two things. Okay, now coming to question number 7. What does the question number 7 says? Describe the principal operations for a 3D printer. So do remember, uh, do remember that it's a 3-mark question. So 3-mark question means you need to write 3 points for the 3D printer. So 3D printers are utilizing, right? They do utilize additive or subtractive manufacturing as well. Manufacturing process of an image developed over a CAD software normally. CAD means a computer aided design software. Okay. Apart from these things, you may write uh, after additive part, binder is poured over it, over a, over an object to give it a solid shape. And if subtractive, so if subtracted, so you may say what is subtract. Okay, do not write this point. Okay, so you could write it down till here. No issues with it. This thing. Okay, now they are saying describe the purpose of a temperature sensor with the 3D printer. Okay, now why the temperature sensors are given with the 3D printer? The temperature sensors are provided to prevent overheating of a printer. It's for 2 marks, do remember it. Overheating of printer by comparing input temperature with range of temperature stored. Okay, next part they are saying a 3D printer contains 1 GB of the dynamic RAM. Yeah, because it is doing the heavy graphics work, so obviously we would be requiring the dynamic RAM over here to store the to store print data. State two advantages of the printer having dynamic RAM instead of the static RAM. Okay, one thing that dynamic RAM is quite cheap as compared to the static RAM. So you may right will be less expensive. The other part you may write that we do not require the fast access of the data, so we can go with the dynamic RAM. Okay, and you may also say that more data can be stored per chip. Per chip means that dynamic RAM is having the data stored in multiple of the chips over there, so we can store more data over there as compared to the SRAM. So what I will be asking you to go ahead to go with the point, no requirement for faster process of data. So the disadvantage of the DRAM could be the advantage in this part. Okay, so that will be all for the second phase of this paper, and we will be continuing inshallah ta'ala in the third phase. Thank you so much, guys. Allah Hafiz for this phase.